All right, so here we are with Shooting Game. This is the second of three core Greenfoot programs that show off a lot of cool functionality of Greenfoot. Let me find it. Here it is. And again, to get this, you just either download it from Google Classroom if it's been assigned. Here, I happen to have it in a Google Drive. You would just, right click it and do download, or if it's double clicked and open, you could find the download button, or if it doesn't have a download button, you could open it in a new window to get a download button, but just do whatever you need to do to download it. And then once you have it, unzip it. On Mac, you just double click it. On Windows, you would right click and do extract to whatever. Once you have it, you can just open it up um, and find the project.greenfoot and let's go. Double click that, Greenfoot opens, and here we are. Okay, so you can see this looks pretty different than Hedgehog. We've got these butterflies or birds. They're called birds. I would have called them butterflies, but whatever. Uh, Nick P, who's made this, has called them um, birds. We've got a cannon, and we're going to shoot these little Krieger cannons, which we'll go through. And you can see the background has its own image here. I'll show you how we did that in a second. So, whoops, where did we go? Yeah, there we go. Okay. I also got this from greenfoot.org. I don't remember where. If I search for shooting game, maybe if I search for Nick P, I'll find it. Nick P, Nick Pod, Nick Poo, Nick Pack. How about this? Krieger Cannon. Nothing. Okay. Well, I got it from greenfoot.org somewhere. I can't remember where. Um, I'd like to credit the original guy, Nick, that made it, another student somewhere. So, a couple of notes. This has custom images and it places all the birds at specific locations, which drives me crazy. I would have tried to randomize that with a loop, but let's look at the custom images. So, normally, um, background. So, instead of calling this my world, he went and called it background. If we look at this, we've got the code for this. Yeah, Nick Peroni. There he is. We got background. We've got these cannons and birds and whatever else. And if you notice, background has an image. Now, let me show you some cool tricks here. So if I want to make a new subclass of world, I right click world and I do new subclass. And there's a bunch of backgrounds you can choose from, but these are pretty basic looking and not that exciting. So if you want to get custom backgrounds, you notice there's a whole bunch of stuff over here specific to this project. I'm assuming this is the kid Nick himself, although maybe it's his friend Krieger. I don't know. Um, Here's the sky image. How are these being made available rather than just all the default stuff that Greenfoot comes with? Let me show you a trick. So if you look at the Greenfoot project here, the project folder, this the Java files are literally just sitting in there. The class files are compiled versions. But one of the things to note, there's this images folder. If we go into this images folder, all of those custom images, they're just dropped in here. So you can do this with your projects. If you drop custom images in here, you can then create things. Oh, he had a plane that he never used. I don't know. He's got some custom images. So, you're like, oh, I want an actor that's a plane. I could do new subclass and I could call it, plane. And I could, where are you, plane? Where's the air? There it is. Plane one. There we go. Boom. So now I have a new, and if I'm like, oh, make a new plane and stick it here, I could do that. Now this looks terrible and I don't actually want to do that. So I'll reset it to get rid of it. In fact, I'll come over here and I will delete this because I don't actually want another class there. But, pretty cool, right? We've got all these custom images because we just stuck them in that images folder. And then when Nick Peroni created everything, he didn't just choose from all of the default stuff. He chose from the custom stuff that he had gone ahead and uploaded. So that's a cool thing about custom images that I did definitely want to take a moment to talk about because I think it's going to open up a lot of potential for you in making whatever kinds of games or puzzles or interactive experiences that you want to make. If we look again at this background in the editor, background, we've got super, we chose a width of 700 and a height of 388 and 1 pixel, 1 by 1 pixels. I don't know why these numbers, you just pick these numbers. Prepare is just this private helper method that just does prepare. And so you can see the first thing it does, it creates a cannon and puts it at a certain location, 63, 327. Well, if you think it's out of 388, so 327, that's about here, and 63, that's in a little bit. That's about 63 by 327 for something that's 700 by 388. I don't know. That's how the maths on that one. And then for all these other birds, we have bird two, bird three, bird four. We're just like creating them, and he's got specific coordinates for each one. I would absolutely randomize this with a for loop. Now, one good thing you notice is there's no birds overlapping. So, like if you did it with a for loop, you have to be like, oh, add the bird, and if it's touching another bird, remove it, and then pick another random location to put it in there, so you could get all the birds randomly dispersed, so it didn't look exactly the same every time, and you didn't have to like pick these specific numbers. I've always wanted to do that. I've just never really bothered or taken the time. Because if you notice, these are all local variables. Like we're not storing these in instance variables. The way we're going to interact with these is just by doing, am I touching a class, and then removing classes that I'm touching, removing instances of classes that I'm touching. So we actually doesn't actually matter that these have separate names. We're not going to use like bird two, bird three, bird four. We're not going to use those names for anything. So how do we figure out these numbers? I don't know. Probably Nick went and figured out what these numbers were and decided to go with those. That is great. What do we got? Okay, so bird. What does a bird do? It moves and then it maybe turns a little bit. So this is the bird class. We're gonna add. Well, I have it in the slides, but I'll would like to just show you in the code here. So bird extends actor. Why are we extending actor? Well, because birds are actors. They're entities in the game that can move around. So the act method moves to. What direction does it move in? Well, it moves in whatever direction the bird look like butterflies, but whatever. I'll go with bird. Whatever direction the bird's facing, it moves 2 pixels. Then we call random turn. This is interesting. This greenfoot.random number, this method, and we can look this up in the API if we're not sure. We can go up here, be like Greenfoot. Hey, guess what? Here's Greenfoot. Let's find get random number. Returns a number between 0 inclusive and limit exclusive. So if you put 100 in here, it's going to generate a number from 0 to 99. So we're generating a number from 0 to 99. If it's less than 10, we're going to do this. We're going to randomly turn. Okay, so 10%, so the birds move 2 pixels at a time, and 10% of the time they turn some amount. How much do they turn? Well, they turn, here's another random number formula. So random number 90 generates a number from 0 to 89, and we subtract 45 from it, right? So 0, if you subtract 45, that gets negative 45. 89, if you subtract 45, goes to 44. So it goes from basically negative 45 to 44. I think he wanted 45, negative 45 to positive 45, but because 0 is included in here, it sort of shifted it over one a little bit. Doesn't really matter. You're not going to notice a 1 pixel difference in like exactly how it's aimed. Who cares? The point is 10% of the time it turns, not a huge turn, but just a little bit between, if this is your heading, it's going to turn from negative 45 to positive 45, not 90, just 45s, you know? So that's kind of cool. That's a very simple amount of logic and work to get kind of interesting bird behavior. So that's very cool. So that's what birds do. Now, what do cannons do? Well, basically rotate and fire. Let me show you how that works for cannon. So if we look at cannon, we got this act method. And remember, act gets called approximately, you can think of it as like 30 frames a second or something like that, or 60 frames. I'm sure it's not 60 frames a second, but it gets called a bunch of times per second because that's how computers pretend they're doing animation, is they just keep redrawing the scene over and over and over again a bunch of times per second so fast that our eyes can't really detect it, and it looks like there's animation going on. So we only have three keys we can use: left, right, and space. So if the key down is left, we're going to set rotation to whatever the rotation is, -5. This is different than set location. Rotation is what direction I'm going to start using the term sprite because these entities, really they're sprites. Sprites, I don't remember the etymology of sprite, but it's the standard term used in 2D video games for like a character. Like Mario is a sprite, or Bowser is a sprite, Metroid or Samus, she would be a sprite. Whatever it is, you're going to have these sprites which are like, typically your player character or enemies or something like that, whereas like backgrounds are not really sprites. Those are like images or something like that. So really things that move around and do stuff, we tend to call them sprites. So this cannon sprite, it doesn't move, it just turns left and right. So it's here. If you tell it, left, that's going to set the rotation up a little bit. Right will set the rotation down a little bit by 5 degrees. So you can kind of move the cannon around. And if you hit space, it's going to fire. Now, this is interesting because is key down left and right? I think this is so you can hold it down. Um, Whereas we're doing space equals get key. Does that mean you can hold? I think you can hold it down for both of these. I don't. Let me say it this way. This, Greenfoot dot is key down left, versus if space equals Greenfoot get key. The differences here is key down left, repeatedly checks if the left key is down or if it's held down. Space equals get key. If get key is null, meaning that there's no key pressed down at all right now, this keeps returning null, that'll be fine. If we reverse these, greenfoot.getKey.equals space, that could throw a null pointer exception because if this returns null and you try to call equals on it, it'll crash. Like it'll get a null pointer exceptions. That's why that's in this order. Why this isn't greenfoot.isKey down space, I can't really remember, but for some reason it's not. Also, the spacing is a little weird here. Like this is tabbed in. I don't really know why. This is tabbed in. I don't really know why. This one's not tabbed in. I don't really know why. I'm not really sure. The spacing and the tabbing doesn't have any functional effect. It's just stylistically, this is a little bit sloppy. I would go in and clean this up if it were me because I'm obsessive about my style. Then I want to spend more than a fraction of a second looking at anything. I want everything to look like exactly what it means because when you stare at code all day long, you don't want to have to spend any extra time figuring out what something does. If something does something obvious, you want it to look exactly like it does something obvious and no different than what the obvious thing is. Because so like this looks a little weird. Like, why are these different? Like the fact that I've spent any time thinking about that is like just a waste of brain energy because it doesn't mean anything different. And so you just don't want to confuse people. Anyway, moving on. Let me show you what this does because it's going to be a little tricky to understand how firing works without me running the game. So let me go ahead and run the game. So here we go. We've started it up. So you can see these are moving two at a time, and then turning randomly about 10% of the time. So I can use the left and the right arrow. I'm holding it down to get the thing to turn. And then I can hit space. And I can't hold space down. That's why he did it that way. So I can hold left and right down because we're checking is key down. But since we're just checking get key for space, we can't hold it down. And so you can see when I fire, if I hit a butterfly, and I'm shooting pictures of this kid, which I assume is the author of the program, but maybe it's not. Maybe it's like his friend, or maybe it's like some famous actor that I don't know anything about famous actors. And when it hits things, you see this like horrible, terrible vision of like, oh, show up, which is kind of cool. So let me, look at this. I don't know. Very cool stuff. So the cannon, left and right, is key down. That's so you can hold it down, so you don't have to keep like hitting it if you want to turn a bunch. But this with space equals get key, this can't hold it down. If you hold it down, it just registers the get key once and then checks it to space and only calls fire once. Let's look at the fire method. So what does this do? This creates a Krieger cannon, which is basically the bullet, the kid's face. We'll see that in a second. It's going to get world and it's going to add the object. So get world is something actors can do. It gets the world that they're in. Because the add object method isn't in actor. Actors don't own all the objects. The world owns all the objects. So actor can call get world because an actor is in a world. So it knows that, what world it's in. So it can get its world and then it can tell that world, hey, add this object at this location. So when we hit space to fire, we create a new instance of Krieger cannon. We add this Krieger cannon to get X, get Y. Well, get X, get Y of what? Well, of the cannon. So wherever the cannon is, it's going to stick that face over it. It's going to set the rotation to get rotation. What's get rotation? That's the rotation of the cannon. So if the cannon's rotated all over here, it puts the face down and rotates it to match the cannon. That's why if you look at this, the faces are always kind of at the same rotation as the cannon. They're not always like this and just moving at weird angles. Um, oops, there we go. So get rotation gets the rotation again of cannon. Why? Because cannon extends actor, and get rotation is a method you inherit from actor. You can always call get rotation. That tells you, where zero, this is 0 degrees, 90 degrees, 180 degrees. It tells you basically how many degrees, what your heading is. And then setting the rotation of the Krieger cannon moves it. This move 40 means once you have it in a direction, you're going to move it 40 pixels. Why? So it's not sitting right on top of the cannon. We want to move it a little bit. And then that's all we do to fire. Now, because Krieger cannon is itself an actor, it's going to then have code in it to tell it how to move and what to do when it intersects things. The cannon doesn't have to worry about that. It just has to create it, put it in the right spot, rotate it, move it a little bit, and then we're fine. Then the cannon's done with its role. So that's not a ton of logic for the cannon. That's all it really needs to do. Let's look at good old Krieger cannon. So Krieger cannon, these are the little bullets. What do those do? Well, the act method, which again gets called, think of it as 30 frames a second, it's going to move 10, and then it's going to splatter. What does splatter do? Well, it checks if it hits anything. So if it's touching a bird, it's going to create a new Krieger. I'll show you what that does. That's basically the big face. I'll show you what that does in a second. Now it's going to get world and add the Krieger object to get X and get Y. So basically it takes that Krieger face and it puts it over the Nick face. And then it's going to remove the bird that it's touching. Now, how does the Krieger face go away? Well, Krieger is itself an actor, so it has an act method, and I'll show you what that does in a second. And this if is at edge, get world remove object. Why is that there? Well, that makes sure that you can remove the object. Oh, I should also mention this code has been updated. If you look at no, I guess it hasn't been. This code's been updated. Never mind. Yeah, it removes this. So this in Java is a special variable that means the current instance. What does that mean? That means Krieger cannon's a class. There could be many Krieger cannons. How would that happen? Well, if I run this, I hit space a bunch of times. Each one of these is itself a Krieger cannon. But not all of them are touching birds. Each one of them has its own identity, its own XY coordinates, and its own set of butterflies or birds that it may or may not be touching. So when we call splatter, each one of these 30 frames a second checks, hey, if I'm touching a bird, create a new Krieger, which is the face that goes over me, which ends up deleting itself after 5 milliseconds. I'll show you how that works in a second. Adds the Krieger object to my own XY coordinate. So it covers the face for a second, removes the bird that it's touching, and that's that. If is at edge, get world remove object this. This is the current Krieger cannon of however many Krieger cannons are in the world. Get world, again, gets the world that owns the cannon and all the Krieger cannons and all the birds, and remove an object. Which object this? What does this mean? It means the specific instance of Krieger cannon. This is how the Krieger cannons disappear when they get to the edge of the screen. They don't just keep flying off out of bounds into infinity. It's possible to write code where that doesn't happen, where things just keep going. It's going to eventually slow down because all your Krieger cannons just go off forever, and then that causes all kinds of problems. Anyway, so this cleans stuff up when it gets to the edge of the world. This creates the face and removes all the birds that it's touching. And yeah, the act is just move 10 pixels and then check if you're hitting anything. So this leaves us with the Krieger. How does this work? This is actually really cool. So this Greenfoot.delay, this is in the Greenfoot class. We have this method delay the current execution by a number of, this isn't milliseconds, it's time steps. So that's basically essentially frames. You can think of it as frames. So if we're doing 30 frames a second and we delay for 5, that's 5 frames. And if there's 30 frames a second, 5 out of 30 is 1/6. So that's a sixth of a second. So it's actually a lot more than 5 milliseconds. 5 milliseconds is instantaneous. You couldn't even notice 5 milliseconds. So this delays by 5 frames the current execution. So let me show you how we kind of know that that's happening. So this, if we run and we fire, see how everything just kind of like glitches just a little, like everything just slows down. Watch when it's hitting things, other birds don't move for just a tiny fraction of a second. That's what it means to delay. So the Krieger, as it's acting, it delays everything for 5 frames, and then it removes itself. And the way it removes itself is kind of weird. Get world means get the world that the Krieger's in. Okay. And the Krieger is just like the happy face that goes over the Krieger cannon. And then after those 5 frames, remove objects. What objects? Get world. Okay, just get the world again. Get all the objects of type Krieger. So it removes all the Kriegers that are in the world after these 5 frames. Um, why all the Kriegers? Like, why are we getting so get objects gets a list of Kriegers that are in this world, and then remove objects removes whatever list this has. So I mean, what's the difference between that and just doing this? Let me show you. Get world dot remove object this, right? So delay for 5 frames and then remove yourself from the world, remove the Krieger. So I think this is fine, right? I think this, has the same weird effect where it's a little glitchy, but it removes itself as appropriate. So I just think this is fine. I don't know. I don't think it's necessary to do all of that. I think this, I mean, I don't think you'll be in a situation where there's multiple, because if there's multiple Kriegers both touching something, it'll delay for 5 frames and then remove both of them. I guess that's fine, but I think that's unlikely to be a major issue. So this gets all the Kriegers and removes all of them, but we know we want to just remove this one after 5 frames. So I don't see any difference here. Um, I left it this way, but I just wanted to show you because that's how it was in the original code. But I just wanted to show you, like, I'm pretty sure you could just remove this. Um, so that's really everything in this. There's this, and then I put this in here. Could we just do this instead? I think we can. That's everything we have for the Krieger. The what is this called? ShootingGame Nick P. Good old Nick Peroni with his Krieger cannon. Um, I don't know. I don't. This again, not super complicated. Uses some custom images. Uses rotations. Uses this delay function. Uses a little bit more complicated intersections and remove methods, but still not a ton of code. Sophisticated, interesting, demonstrates features, and really just opens up a ton of possibility for to get your creative juices flowing. So I think this is a really good sample project, and I'm pretty excited that people can do things like this in the intro class. I'm gonna stop this video here, and before I record the third one, in case I make mistakes and have to, and then I'll just release them as 3 videos, or I'll splice them together.